Yeah, let's start to learn these new topics. Quadratic relations. Okay, yeah, quadratic relations.
Okay.
In Algebra 1, we learned the parabolas. Okay, let's see here. So in Algebra 1, the parabolas we learn is something like this. Okay, this is a parabola. It opens up, right? It opens up, and it has the axis of symmetry, like this. Okay, it's opening up, so the a is going to be bigger than 0, and the function is y equals to a times x squared plus bx plus c, correct?
Yes.
Okay, and this has a vertex format. Y equals to a times x minus h parentheses squared plus k. All right, yeah. This is the vertex format. The vertex here is called h comma k. All right, this one.
Okay.
Yeah, this is what we learned in Algebra 1. If a is smaller than 0, then you're opening down. Okay, you're opening down.
Okay.
But since this is Algebra 2, we are going to learn something even harder. The parabola can open up, opening down, but it can open to the left or open to the right. Okay, so today we are going to learn something new. Okay, when you draw this parabola, there are something new concepts here. You draw a parabola. That point is called the vertex. Okay, yeah, I want you, let's first draw, yeah, get your graph paper ready, get a ruler, okay? Use your pencil, draw the x and y axis.
Okay.
And put this center, write down 0, 0. Okay, I write down 0, 0. That's the center. And this center, your vertex point is also on the center. So you also write down vertex at this location. Okay, I write down vertex for this. And the point over here is called a focus. F-O-C-U-S, focus.
Okay.
And the other direction, you draw this direction, and then this point is called the focus. And this direction, you draw another line, horizontal line. You write down directrix. This horizontal line is called the directrix. In Algebra 1, we learned about parabola, but we didn't learn the physical definition of a parabola. For a parabola, it is defined as this, okay? On the parabola, any point on the parabola, you have equal distance from the point to the focus, from the point to the directrix. That equals to that. Okay?
Okay.
Yeah, you can get any point on your parabola. That thing always equals to this distance. That's a definition of a parabola. Okay?
Okay.
Now let's see. What's the use of this definition? So let's first, I want you to mark directrix. Mark here as vertex. Mark here as focus. Okay?
Okay.
And then you draw a point. You write down N, okay? Capital N. It's a point on the parabola, okay?
Okay.
Now, the definition of a parabola is any point on the parabola. The distance here is equals to the distance here, okay? So,
Okay.
okay. And also, Yeah, so that's directrix. This is called directrix. Focus, and this point is called the focus. Axis symmetry. This is called the axis symmetry. Okay, your left
Okay.
and your right are identical. Vertex. This is a vertex. Okay, and the last one we wait until we finish showing this.
Okay.
Now, I already say that distance equals to that distance. Okay.
Okay.
Now we want to figure out the distance from this point to this point. Okay.
Okay.
The distance formula is in geometry. I teach you this distance formula. In a coordinates, you have 2 points, x1, y1, x2, y2. And the distance between these 2 points is going to equals to this, right?
Yes.
Now, based on this, I want you to write down from here to here. N, I don't know what is N. I put it as X, comma, Y. Okay. F is already marked here saying this is P. So I write down 0, comma, P. Okay.
Okay.
This distance is P. So I write down 0, comma, P. And N and F. Okay. So can you calculate the distance of NF using the given formula here? NF. Okay. So NF, that should equals to okay, that should equals to what?
Wait.
Your N is X, so you do X minus 0 square. Because the F, point F, the 0 is the X value. So you do X minus 0 square plus Y minus P square, correct?
Yes.
Okay, so you have the NF distance. Now, you want to calculate the distance from this point to this line, right?
Yes.
How do you get the distance over here? You draw a perpendicular lines. That's 90 degrees. So this point should be what? This point Q, okay? Because this is perpendicular, so this guy is X. This guy should also be X, right?
Yes.
And this is Y, and this Y should be negative P, right? This is positive P, this is negative P. So your NQ, the distance, NQ equals you want to get your X minus X, right?
Yes.
Square, okay, because that's X, and then Y minus,
What? Plus P.
because here is negative P, so it's Y minus negative P, which is Y plus P, right?
Yeah.
X minus X, parenthesis square, then P, and then Y minus negative P, Y minus negative P, that's Y plus P.
Yeah.
Okay.
Okay.
Now, the definition of parabola is saying that is equals to that. Okay. So you want to make this two piece equal, all right?
Okay.
Let's make this two piece equal to find out what's going to happen, all right? Yeah, let's do that. Yeah, something will happen very nicely, okay?
Okay.
The definition of the problem make these two equal. Okay, this is by definition of parabola. So you can list that guy. Okay,
Okay.
that makes sense, right?
Yes.
Now, this equal, and we can square both sides. Okay, let's square both sides. In that way, we can remove the square root. So this is x squared plus y minus p parentheses equals. This is 0. This can be go away. Okay, this can be gone.
Okay.
Correct?
Yes.
Then let's open them, okay?
Okay.
Yeah, let's expand this. We learned about those formulas before. That
Yes.
guy equals to y squared minus 2py plus p squared. That guy equals to y squared plus 2py plus p squared. Correct?
Yes.
So this term, that term can be gone. Okay?
Okay.
Who else? That guy,
Y squared.
this guy can be gone. Okay?
Okay.
Now you can make x squared equals 4py. Correct?
Yes.
Yeah. So you see here? That's very interesting because originally the parabola function looks kind of like complicated. But now you can change this to a very simple format. Yeah?
Yeah.
That's interesting. Now, you might wonder how we can change that kind of format to this kind of format. Okay, so let me explain you this.
Okay.
For example, our old parabola function is y equals to, for example, x squared plus 2x plus 1, right? This one.
Yeah.
That's our original shape like this. How do we convert this guy into this? Okay, so the trick is here. You first complete your square for your right. Yeah, and this one. And suppose you are doing those kind of transformations. Remember, this one is your vertex located at 0, 0. Right?
Yeah.
And then you can say you do a shift. So the general case is you have x minus x0 squared equals to 4p times y minus y0. Okay? Yeah?
Okay.
And not always that your vertex be in the center. You could shift it to a x0, y0 location. Yes?
Yeah.
In this way, you can change this guy to be x plus 1 squared equals to y. Y is 4 times 1 over 4. times y minus 0, okay? Yeah. So
Okay.
that means this parabola has a value p equals to 1 over 4. And also the center is at x equals to -1 and y equals to 0, okay?
Okay.
Yeah, so this is another different explanation of the previous standard format for the vertex, for the parabola, okay?
Okay.
Yeah, and the reason they call this guy as a parabola is when you, okay, so you say this way. You stand, for example, you stand like, yeah, at a building, okay? You stand at a
Okay.
building. And you threw away something, okay? I
Okay.
threw a stone at a certain angle, and your stone is going to be fly on the air, and then eventually it's going to drop down, okay?
Okay.
This curve is called a parabola, all right? This
Okay.
curve is called a parabola. That curve is just the same guy we are talking about. This one is opening down, so you can go down, okay? You can
Okay.
opening up, all right? Now, the new term we learned here is called the lattice rectangle. The lattice rectangle is defined as you start from your focus point and you draw a line perpendicular to your axis symmetry, okay?
Okay.
Yeah, this is your axis symmetry, and you draw a line perpendicular to that, okay?
Okay.
Now, you want to find out lattice rectangle point, okay? So one point is on the left, one point is on the right, okay?
Okay.
So they didn't tell you this point location. We can get it by ourselves. So let me show you how we can calculate this value by ourselves, okay?
Okay.
Yeah. Yeah, let's calculate the m and the m prime. The way we calculate the point m location is because this line, because it's perpendicular to the axis symmetry. So this guy will have the same y value as the focus, okay?
Okay.
Any point on this line, the y will be what? P, right?
Yeah.
Okay, so you can plug in. You can see over here, you can say when your y equals to, so this is moving, shifting to any other locations. And right now we are still talking about when the center is at 0, 0. When y equals to p, x squared equals to 4p squared. X will equals to 2p or negative 2p. Okay,
Okay.
right? Now the lattice rectangle, okay? The lattice, you may have to also know this new words, okay? And remember how to spell. Lattice rectangle, 2 points. Your left point is negative 2p and p. The other point is positive 2p and then p, correct?
Yes.
So now you can finish. Yeah, so previously, this part, we only talk about the simplest case. The center is at 0, 0. So let's summarize all those different points locations, because in the quiz or test, they will ask you all those locations, okay? So
Okay.
for the simplest case, let's see here. Let me summarize this, okay?
Okay.
Okay. So when center at 0, 0, that is x squared equals to 4py. Okay.
Okay.
Center at 0, 0. Okay.
Okay.
And if x squared, x minus x0 squared, we do a shifting, horizontal, vertical shifting. Now, this is another one, right?
Yeah.
Now we can do, if the center is 0, 0, then the focus you see the focus location, that's 0p, right?
Yes.
Okay. So we write down 0p. Okay, 0p. And the directrix is y equals to negative p. Yes, it's a horizontal line. So now I can, and of course the vertex is always, so we can write down the vertex as the first one. That's the easiest one. The vertex is 0, 0. Okay.
Okay.
And to this right one, so yeah, we finish the simplest case, then we can easily do all the shift. Okay.
Okay.
After directrix, we can write down the lattice rectangle. Okay.
Okay.
And also axis of symmetry. Axis symmetry is who? Is x equals to 0. X equals 0. Okay. Yeah. Now we want to finish the scenario when the center is not at 0, 0. Okay. So
Okay.
we want to move this one to the left and then finish all this part. Copy and then paste for this right one. Change color to the blue. All right. Now let's finish this. For this guy on the right, the vertex is not a 0, 0 anymore. It is x0, y0, right?
Okay.
Okay. The focus and each point is going to shift it with the same amount of your vertex. Your old one is 0p. Your new one is x0 plus 0, which is 0, and then y0 plus p, right?
Yeah.
Okay. Your directrix, your previous is y equals negative p. Your new one is going to be shift with y0, okay?
Okay.
Your axis symmetry is only related to x. Old one is x equals 0. New one is x equals to x0, okay?
Okay.
Lattice rectangle. everybody is going to shift with x0 and then y0. All right.
Okay.
Yeah. So let's change this guy. That makes sense?
Yes.
Okay. So this thing belongs to Algebra 2's conic sections. Okay, conic sections, which is one of the hardest topic for Algebra 2.
Okay.
In school, when they teach you this, they will give you those formulas, say, hey, you remember this. They give you this table, okay? And they ask you to remember all those locations. It's too hard to remember them without doing mistakes, okay? So the way I teach you this is different with the way school teacher teach you. I want you, for anything, you want to make the simplest case treated at the center 0, 0 first, and then we do all those shifts, okay?
Okay.
So yeah, for example, in school, they will say, okay, you go ahead, remember all this thing listed in the table. Yeah, you have this format. Yeah, first you see here as your format, and then you want to remember your vertex is at HK, then out toward here, and then you want to say x equals to h, and then you want to remember your focus is this, the directrix is this, and you also need to know that if the parabola is open horizontally, you need to remember this. I tell you, after you do many questions, you kind of feel dizzy. You don't know which one to put where, okay? So I want to show you the way I do this.
Okay.
I never use this formula. It's too long, too hard to remember, and very confusing. So let's see here. X minus 2 squared equals to 4 times y plus 3. Today we already derived the parabola opening up, okay?
Okay.
If I put this as center, then x squared equals to 4py, right?
Yeah.
Okay, yeah, so I treat this as a center, okay? I treat this point as my center. Then 4py. This is, I don't care of this inside first. I will take care of it later, okay?
Okay.
4py. This is a 4, so that means my p equals to 1, right?
Yeah.
4p equals to 4. So p equals to 1. If p equals to 1, then we can say vertex. Now, vertex is easy because you make this guy equals 0, okay? You make your square term to be 0. So your vertex will be, make that equal 0, x is 2. This thing to be 0, y is negative 3, right?
Yeah.
Okay, so that's this vertex. Axis symmetry. I remember your axis symmetry is that through that center.
Yeah.
So you want to make that term equals to 0 and x equals 2. Axis symmetry is make your square term to be 0, okay? And make your
Okay.
square term to be 0. You want to write down the sentence, okay? And now focus. Remember when we draw the parabola just now, okay? Yeah, each time you can quickly draw a parabola. and you can figure out your values. Yeah, we have a parabola like that. This part from here to here, the top one is P, right?
Yeah.
This part is P, and P is 1. So our focus is what? Our focus is at 0, P, right?
Yeah.
So the focus is at 0, and then P. P is 1, so it's 0, 1, right?
Yeah.
But everybody has to do the shifting with what? X plus, so our vortex is, the center is at 2, -3. So I need to move my 0 to 2, right?
Yeah.
And then 1 minus 3, which is -2. That makes sense?
Yes.
So we use this we use our knowledge here to figure out everything. And then based on the center, new center, we do those horizontal or vertical translations. Okay?
Okay.
Yeah. And here, remember when we say this is P, okay? This up one, this is focus. And the directrix is this one. So the directrix, the old directrix is y equals to negative P, which is y equals -1. But now you are going down by 3. So this go to y equals to -4. -1 minus 3, -4. Correct?
Yeah.
Direction of opening. The P is bigger than 0, so this guy is opening up. Okay?
Okay.
Yeah. Let's write down the lattice rectangle. Lattice rectangle. You may ask me, everything is showing in the graph already. Why do I need to do it? Listen, the graph won't give to you. Graph has to be drawn by yourself. Okay?
Oh.
Yeah, they don't give you the graph. You get those points, and then based on those values, you draw this one. Okay? This one is after you get this. After you have this, you can draw this. All right?
Oh.
Okay. If this is given, everybody can answer it. Yeah, since it's not given, you need to figure out from here. And it's hard to do this from the formula because it's too much to remember. Yes?
Yeah.
Who can remember so long? After learning for 1 semester, there are thousands of formula to remember. So you want to know the inside the rule. You want to know the background story so that you can figure it out.
Oh.
The lattice rectangle. The lattice rectangle used to be -2p and p, right?
Yeah.
And the other one is 2p and p. Okay, so -2p and p is 1, so that's -2 and 1. The other is 2 and +1, right?
Yeah.
And then you shift x by 2, that's 0. Shift 1 by -3, that's -2. Shift 2 by 2 is 4. Shift -3 from 1 is -2. Okay?
Okay.
That's why this is exactly same one as what you see here. Lattice rectangle, left one and right one. Yeah?
Yeah.
After you get this point, then you draw this. After you know this vertex, you draw this. That's how you say, okay, my parabola passed this. That's why you draw like this. Okay?
Okay.
Yeah. That distance, lattice rectangle distance, let's do here. These 2 points, they have the same y value. their x difference is 4p. So the lattice rectangle distance or length is 4p. Okay?
Okay.
All right. So the lattice rectangle is 4. All right. You can tell from here to here is 4. 1, 2, 3, 4. Correct?
Yeah.
Okay. Now we can see. All right. Yeah, I'm going to give you several. Let's see a few practice. Okay.
Okay.
Let's see here. This one. Okay. Yeah, let's do this question. Let's change this guy to the vertex format. Let's see how we do the vertex format for this one. Yeah, go ahead. You can tell me what we can do.
Vertex format.
Yeah, how do you
Vertex
remember
format
how do we
first.
do the vertex format? We need to complete in the square, right?
Yeah. So wait. So companies are 3 times x squared minus 10 times x, 10x, yeah. And then parentheses, and then plus 71. And then 3 times x squared minus 2 times x times 5. And then plus 5 squared.
Good.
And then minus 3. Yeah. Wait, 3 minus 5 squared.
3 times 5 squared. Okay.
Yeah. And plus 71, yeah.
Equals.
And then equal to 3 times x minus 5 parentheses square. Yeah, wait.
That's right.
Yeah, minus 4.
Very good. Okay. So this is vertex form. What is vertex?
Wait, x equal to 5. And then y equal to 4.
Negative 4.
Negative 4, yeah.
Okay. X is symmetry.
This one. Wait.
You want to make your square term to be 0. Okay.
Yeah.
So who is that?
Then equal to 0.
X equals to 5. Okay. Correct?
Yeah.
We make this guy, so x equals to 5. X is symmetry, you have to have an equation. Okay. Not 5.
Okay.
That's not the answer. That's the answer.
Okay.
Yeah, will this guy get a min or max?
Max.
This guy, a is bigger than 0, so it's opening up. So that's called the mean, okay?
Okay.
Right? That's the mean value, right?
Yeah.
What's the mean value?
3.
No. This guy mean value is this. This mean value is this. Let's draw this one. Okay, let's draw this one. It might feel a little bit confused. And x, when x equals to 5, y is how much?
Y equal to -1.
No. When x equals to 5.
Wait,
Five
there's -4, -4.
Okay, -4. Like this, right?
Yeah.
And let's make x equals to, let's draw x equals to 6. Let's draw the y. Let's go ahead and calculate.
When x equal to 6, y equal to -1.
So that's 6, and then 3 minus 4 is -1. Okay.
Yeah.
6, -1. There. Okay. The vertex has the included the axial symmetry, right?
Yeah.
So they have this, correct?
Yes.
And then you have a reflection, so the point is also on this
Yeah.
side, correct?
Yes.
Now we can connect. Correct?
Yes.
Okay. Let's calculate the x-intercept. How do we calculate the x-intercept? We want to make this equals to 0, okay? Now let's calculate. Now you see, we already make this as what? As a vertex format. So let's do this guy equals 0, which is easy to solve, right?
Yes.
Because this one is not factorable, right?
Yes.
So we make this guy -4 equals to 0. That's why this guy equals to 4, right?
Yeah. And divide by 3.
Then x minus 5 should equals to what? Square root.
Square root 4/3. Positive.
Positive and negative, okay?
Yeah. Positive. 4/3. X.
That equals to, you want to times the 3 for the denominator. Okay?
Yeah.
So x equals to 5 plus. Oh. Correct?
Yes.
So your x-intercept is
5. Positive, negative, 2/3. Square root of 3.
correct?
Yes.
Y-intercept, how do you calculate?
You make x equal to 0 there.
Right.
Yeah.
Okay. Make sense now?
Yes.
Let's draw number 6. Okay, let's draw number 6. Let's also do this guy. Yeah, we want to change this guy to the vertex format. Is the most important thing here. Okay. Let's see here. Go ahead. Tell me what you can do.
1/2. Wait. Let me see. Okay. 1/2 times x squared.
Okay.
18 x.
Hold on. Be careful. Be careful, okay?
Wait, 12x
Okay.
plus 15. Yeah, so equal to 1/2 times x squared minus 2 times x plus, wait, times 6, and then plus 6 squared, and then parentheses, and then minus 1/2 times 6 squared, and then plus 15. So the equal to 1/2 times x minus 6 parentheses squared, then minus minus 3. Yeah.
And this guy is 36, right?
Yeah.
And then negative 18.
Yeah.
Good. So let's answer the question. So that's the vertex we met, right?
Yes.
Okay. Vertex.
Vertex. X equal to 6. And then y equal to negative 3.
Okay. Now let's write down axis symmetry.
X symmetry is like that.
Axis symmetry. Make your look. Make your square term to be 0. So who is that? X equals 6, right?
Yeah.
All right. Make sense?
Yes.
Okay. Who else? Minimum or maximum?
It's minimum.
Okay. Value is?
Y equal to negative 3.
Yeah. Okay. Now let's draw this one. Yeah. How do we draw this one? We want to draw like that. Okay.
Okay.
So when x equals to
6.
Y
it should be equal to negative 3.
Okay. Negative 3. So let me move this guy more to the left. When it is 3, it is, oops. Okay. When it is 6, 1, 2, 3, 4, 5, 6.
It should be negative 3.
Going there. Yes.
Yeah.
Okay. Yeah. Let's give let's give a few more points. Look. I don't want to choose x equals 7 because when x equals 7, that's 1. That's 1/2. It's not on the integer. Can you use like 8, so that we can have more integer points?
When x is a, y equal to negative 1.
This one times 4 minus 3. That's negative 1. Okay.
Yeah.
So 8 negative 1. Right here, right?
Yeah.
Axis symmetry. This, right?
Yeah.
Then this guy was reflected to the other side here, correct?
Yes.
Okay, very good. Now what else? Yeah, we can make one more point. Yeah, let's do one more pair. Make x equals to 10. Let's do one more.
X equal to 10. y equal to 5.
Okay. So when x equals to 10, y equals to 5, you go 2 points beyond here, and then you go up, okay? So this guy is going to be 1, 2, 3. 1, 2, 3, 4, 5, right here. So you will be reflected to the other side, like this, right?
Yeah.
Okay, then you can connect. No, they cannot connect. So let me draw it.
I think you should move one more space to the right.
Hmm?
You should move the dot. The
Oh, yes,
take
yes,
a
yes.
10.
Yes, good catching. Yeah, when I draw it, I didn't notice it. Okay, good catch. Let me. Okay, that's correct now, right?
Yeah.
Okay. All right. Makes sense now?
Yes.
Okay. Okay, so I want you to be very familiar with those vertex format. Yeah, for example, this question, how do we find the, look, algebra 1 only asks up to question up to this level, but algebra 2, let's see what algebra 2 is going to ask us. Algebra 2 is going to also ask you the vertex, right?
Yeah.
But they are going to ask you what? They are going to ask you your focus point, you know, and directrix. So let's see, how do we find out the focus location and the directrix, and also the lattice rank term, okay? Yeah.
Okay.
Yeah, so the formula we derived today is by x squared equals to 4py, right?
Yeah. Yeah.
This one, we can rewrite that guy to the same format. We make y plus 3 equals to 1/2 times x minus 6 parentheses square. All right.
Okay.
So this becomes 2. You want to make x minus 6 square on the left. Okay. Yes.
Okay.
Yeah. This means that 4 times 1/2 times y plus 3. So the p is equals to 1/2, right?
Yeah.
Yeah. Your previous, if the center is at 0, 0, the focus is at 0, 1/2. But now because it is not at the center, so the 0, this is 6, so 0 plus 6 is 6. And this plus 3, the center, the real center, vertex center is 0, negative 3. So this plus this is 6. And then 1/2 minus 3 is negative 5/2, right?
Yeah.
That makes sense?
Yes.
Okay, this is the focus. Focus and directrix, okay? Directrix used to be y equals to negative p. Now because it's shifting down, so y equals to negative 1/2 minus 3, which is negative 7/2. Correct?
Yeah.
Okay, So this is the directrix. Now the last one. Yeah, we can already write down. Yeah, so here we can figure out focus is on this point there. That makes sense? Yeah, this is the focus. And this is directrix. Okay? Yeah.
Okay.
And the lattice rectum is this. All right?
Okay.
Lattice rectum is this 2 points. One point for here, the other for here. Okay? So let's write down the lattice rectum. Lattice rectum, you can simplify it as LR. Okay?
Okay.
LR. The left one, it used to be negative 2p and p, and then 2p and then p. Okay. Negative 2p gives you a negative 1/2. 2p give you a 1 and a 1/2. And then you do the shift. This guy plus 6 give you a 5. 1/2 minus 3 is negative 7/2. And this guy, 1 plus 6 give you a 7. The other guy is negative 7/2. Okay? And you can tell, wow, this point is really 5 and then negative 7/2. This point is really 7 and negative 7/2. Correct?
Yeah.
So your calculation has to agree with exactly the graph. Okay? Your lattice rectum, your focus, your vertex, and your directrix has to agree with everything you have here. That makes sense?
Yeah.
Yeah, I know that this is a little bit confusing, but I believe you work very hard and you, after doing this, you will figure out, okay? So I will send you this homework and I want you to get those answers and also tell me all those points like focus, directrix, lattice rectums, okay? Yeah, for each single questions, all right? Yeah.
Okay.
Not only just finish this part, but also answers those questions because those questions is for Algebra 1 level. This new questions is for Algebra 2 level, okay?
Okay.
Yeah, you do pretty good, yeah. I'm very happy for all your progress. It's really good. Yeah, for you are just 8th grade, right? You are just 8th grade. You can already reach to this level. That's really, really amazing. Yeah, I'm very proud of you. Nice work. Yeah, I will send you this into the Google Drive link. Okay. Yeah, and I also attach some formulas inside. It's okay that something you don't understand. We will revisit this knowledge next week. Okay.
Okay.
Yeah. Yeah. Thank you. See you next week. Okay. Bye.